All right, in this lesson in Physical Science 20, we are talking about molecular formulas. Now, we just got finished talking about empirical formulas, and empirical formulas, as we know, is the lowest, the most simple ratio of elements in a compound. So, hydrogen peroxide, let's say, which has a chemical formula of H2O2. The empirical formula for hydrogen peroxide would be HO, just H1O1. The molecular formula is actually H2O2, which would seem like, well, why don't we just write it in the simplest format? Well, it's the structure of the molecule dictates that we actually have two hydrogens with two oxygens. And so we just got finished talking about empirical formula. If you need to look up on that, you can watch that video on empirical formula. But molecular formula takes that concept of empirical formula, and we actually use the actual molecular mass to decide whether there is a multiple of the empirical formula that's actual formula. So given the empirical formula, we determine the ratio between the actual molecular mass, and that will be given to you, or you'll be able to find that out pretty easily, and you divide it by what would be the empirical formula mass. All right, so let's say we have something like an empirical formula of, let's just say, A to B, okay? And we have, this is the empirical formula, and we have a mass of X. So let's say that the actual molecular mass is 3X, okay? So it's the empirical formula mass, but it's actually exactly 3 times as much. So what we'd be doing is we'd have to figure out what is the actual molecular formula. And so what we would do is we would times all of these coefficients, or sorry, all of these subscripts by 3. And the actual formula then, the molecular formula, would be 2 times 3, which would be 6. And B1 times 3 would be 3. And so that's how we would do that. So it's the ratio of the empirical formula mass with the actual molecular mass. So when we find this ratio, we multiply it by the empirical formula ratio, and we get the molecular formula. So let's do an example here. So here's an example that I've already got started for us. So the example says this: what is the molecular formula of a substance that has an empirical formula of this, AgCO2? Now notice this is Ag1, C1, and O2. That's the lowest, the simplest ratio of those elements in that compound. But the actual mass, they said, is 304 grams. So this is how you do this. You find empirical formula first, and again, if you need to watch that other lesson on finding empirical formula, you have to do that first. If they give you the empirical formula and the actual mass, then this is how you do the question. So the empirical formula mass comes from 1 silver, and so here I just got a snapshot of the silver from the periodic table. So that's where I get this number from, 107.868 and 2, and the one that I used. So use all the decimal places that you can on your chart. And that's one of those plus 1 carbon, 12.011. And then because in our empirical formula we actually have 2 oxygens here, we would multiply 2 times the mass of oxygen, which is 15.9994. And so if we add those up, that should give us a grams per mole, an empirical formula mass of 151.8778. And that's actually grams per mole of this compound AgCO2. That's what this weighs. Now, of course, the question says the actual molar mass of this compound, or the molecular mass of the actual molecule with whatever subscripts the actual molecular formula has, is 304. So, as our notes dictate above, we simply take the actual molecular mass and we divide it by the empirical formula mass. So this is the easy part. So you take the actual, which is 304 grams, that's what we're given, and you divide it by this empirical formula mass. And of course what we get here is we get pretty much exactly 2.00 something. 9 something. But it's pretty close to 2, and so you're going to use that number of 2. And so what that means, of course, is that instead of having 1 Ag, 1 carbon, and 2 oxygens, we have 2, double what we would normally have. And so you could say that your molecular formula here is Ag2C2O4. You don't have to use any brackets or anything like that, just double whatever is given, and this would be your actual molecular formula. So given what we're given, the mass, this is the molecular formula of the actual compound right here. Okay, so that's how you do that, that type of question. And again, if you need help with empirical formula, you can look up that other video. So here's the assignment that just was for the end of the class, for my class out of the Merrill Chemistry textbook. But there's your notes and your example.